Hi friends, let's discuss today how to read and interpret execution plans. I have taken this SQL query to explain. Okay, this is present in the one of the Oracle docs here. Oracle optimizer explaining the explain plan. Okay, this is the SQL query they explained here. Here, this is the SQL query I have taken, and explanation is given like this. It is a good explanation. You can go through it. Okay, let's discuss. Let's jump into the topic here. How to read this explain plan. I have generated the explain plan and pasted here. So here first, if we see the approach should be bottom to top. Okay, it is the tabular representation of the explain plan. Okay, if we go to the tree based, okay, here from Oracle doc, this is bottom to top. We have to read from bottom to top like this. Table access products, access sales, next hash by, hash join, and group by. So here we will see the indentation of these lines in this tabular representation. Here, what is meant by indentation? What represents actually the indentation in Oracle's execution plan represents a tree hierarchy, parent-child relationship. The deeper the indent, the lower the operation is. Means which operation is performed first in that SQL query, which is the lowest operation. So which is in the deeper indent that will get processed first. So see here, if we go from here, select the indent is hash. The next horizontal position of this line is somewhat little bit okay. There is a gap right here. So from this line to this line, there is some gap here. Again here there is some gap. Okay. So if we move like this, select to hash and here to here and here to here, and this table and view are in same indentation, same horizontal position. We will see this later. Okay, and after this again there are three lines which in this view mean this belongs to the left part of the tree. So if you go to the document here, see this will become the left part of the tree. Okay, so here now from view again there is a in the hash group by line which is there is some gap. Okay, from here to here partition and partition to table access full. So this is the this is the lowest operation which will get processed first. The deeper the indent, the lowest the operation is. So from here we have to start. So first it will process table sales. How it is processing? It is accessing full table access. Okay, full table access. And how it is accessing? It is a partition table, so it is accessing by partition range all. Why range all means? There is no column on the time id is the column where these partitions are created. Okay, so there is no filter on the time id, so partition it is accessing all partitions. Okay, and table access full is processed from here to, we will take other color here. Okay, it will process from here to here partition range, and it is grouped by hash group by will done, and it will be formed as a view here. Okay, it will be formed as a view. That it view name is view underscore gbc5. Gbc is a based costing, group based costing. It is the internal Oracle optimizer engine will create this view. Okay, this view and these two are in the same indentation, right? Here we can see indentation means same horizontal position. These two lines are starting. Okay, here. So these two things. This is also a table, and view also is a virtual table. So these two are joining by hash. Hash joining is happening on these two tables. One is view and one is the products. So and after performing hash joining, and it is grouping, hash group by is happening, and after grouping it, and it is given a output to the client with this select statement. Okay, final output will be provided by this select statement to the end user. Okay, So what is this group by costing means? It pre-aggregates sales by prod ID before join, reducing rows passed through to hash join from 489k rows to only 767. Okay, here if you see, here we have 489k rows. Okay, from 489 to, while giving it to hash group by, okay, here while forming view, it is converting this many rows to 767 only. Okay, see this view will have 767 rows only, and this products will also have 767. So here cost is reduced to process this join, this hash join. Cost will drastically reduce. Okay, because 489k rows will just converting to 767 only. Now moving down the document here. So this is the flowchart representation of that explain plan. Step 0, 1, 2, 3, 4, 5, 6, 7. Here step 7 is, here step 7 is actually table access full. This is sales table. Okay. Here see step 6, this is the left part of the tree. Okay, this is the left part of the tree, and this is the right part of the tree. Okay, I told you, right, this table, products table and view, both started in the same horizontal position in the tabular representation of the explain plan. So both are in the same indentation. So it looks like this. In the tree format it looks like this. Okay, if you go here, see, here table and view are same indentation, so it will be represented as like this. It will become left part and right part, and these two are in the same indentation here. Okay, move further down to the document here. Step 6, 7. This is the, I told you, right, deeper the indent, which is in the deeper indent, that will process first. So step 6, 7 will be processed first. So we will see what Oracle does here on step 6 and 7. There is no where condition on time ID. So Oracle must scan every partition of sales table. Okay. So it will process all 17 of them. This is called partition range all. Step 4 and 5 this here. Step 4, step 4 and step 5. Here, what is happening here, step 4 and 5. Pre-aggregate sales before the join. It is forming group-based optimization. Instead of joining 489k rows to the products, okay, Oracle's group by costing transformation pre-groups sales by prod ID first. Okay, we will see this practically in a in the database. Okay, I have created virtual environment in this setup. I have a setup. Okay, I have generated this scenario already, so I will show you. Okay, after step 4 and 5, 4 and 5, these two will, this table, products and view will be hash joined here. Okay, step 3 and 4. If we go here, step 2 and 3, hash join, match products and pre-aggregate sales. Okay, this is the products and this is the view. So all are available here. You can go through it. I will provide this document. You can go through it. And step 1 is the final one, hash group I, compute average per category. Here 767 joined rows, okay, will be taken and provided the output. This average will be calculated, and select statement will be give the output to the end user. So after this, going down to the document, any questions? Okay, by questioning only you will learn more. How many doubts you will get, that much of learning you can gain. Okay, the first question is how the SQL query will be written for this grouping. Here view, here view is it is generating a view internally, right? How the SQL query will be written? by the optimizer internally, okay, to generate this view, to form this view. Okay, this is the actual query. This is our original query here. Up to here, this is our original query. What Oracle internally rewrites it to the GBC equivalent is this one. Okay, this is the internally Oracle optimizer engine will return. This is the innermost query here. This is the innermost query. Okay, select prod ID. This will be this the output of this will be given to view, written as view in this view. Okay, view underscore GBC underscore file. Okay, from this view, this products, this products table and this view will be joined, hash joined. Okay, and the final result will be provided to the end user. Okay, this is the this is how the actual query Oracle internally returns rewrites. Okay, so moving further down here, why does GBC use sum divided by count instead of average directly? Okay, say average is not associative. You cannot average averages across groups. Okay, see average of group A plus average of group B divided by 2 is not equal to average of all rows. Okay, so that's why it will first group A, this is the group A. If we see in this group A, it is sum and count, taking sum and count. Okay, after again this, it will taking here sum and count, sum of view dot sum amount and sum of view dot count amount. Okay, so we will see this practically in the SQL developer. Okay, I have a database setup. I will show it to you. Okay, moving further down. So next question is I will take this. I have taken this explain plan again here. So hash join here up to here, which query is processed, and this here up to this, which query is processed. Let's see. See here, Oracle, how Oracle sees it internally. Here, your SQL, how Oracle sees it internally. Like this, internally, the query will be rewritten. Step 7. This is the step 7 here. Table access full sales. From sales, read prod ID amount sold only. The physical read for each partition, Oracle does a full segment scan and reads every row. Only two columns are projected, prod ID and amount sold. Everything else is discarded immediately. Okay. So moving further down here, partition range all, node 6, partition range all here. From sales, no where condition on this time ID. So it should process all partitions 1 through 17. Okay, no time ID filter exists in the query. So Oracle cannot skip any partition. It must visit all 17 partitions. Okay, so after this two process, it will go to group by, hash group by here. SQL fragmentation, this node executes group by prod ID. Sum of amount sold and count of amount sold. It will take sum and count of rows and it will group by using hash function. So groups 489 raw sales rows by prod ID and compute sum and count of the amount sold. Okay, result is 767 rows, one per distinct prod ID. So here 489k rows, 489,000 rows will be converting to 767 rows only. Okay, here in node 5. Here if you see here in the here step here, hash group by 489k rows to 767 rows. Okay, further down, moving down, node 4 view select prod id, this one from sales group by prod id. This is the boundary of internal gbc subquery. Okay, you will read this document. Okay, if I explain step by step means the video will become lengthy. You will go through this later. Okay, then move to the node 3, table access full products. Reads all 767 rows of that of this products row, products table. Products table contains 767 rows, so it will read all the rows. It is accessing full table scan. It is accessing through full table scan. Okay, next, node 2 is the hash joining here. Step 2, hash joining. Join on prod id equal to v dot. This is the view gbc v dot prod id. Okay, here it is having 767 rows. It is also having 767 rows. So cost will be reduced. Here, next node 0 step, top of the node, select statement. The output will be given to the end user using this select statement. This is the root. Okay. Hmm. Okay, moving above here, if you observe the color code here, okay, say this 6 and 7 color code is matching to this. See, this 6 and 7 here, this color code is matching to this thing, these two lines. So here, first 6 and 7, this sales tables is processed. 17 partitions are scanned. And moving to 4 and 5 steps, this color code is matching where? Here. These three lines and this to this. So up to this, it will get processed up to this step 4. Okay, these things are processed like this. This is the subquery color code. If you see the color code of step 3, where is color code of this blue color? Here it is products. Okay, here it is accessing. The table products is accessing here. Okay, so then purple color, the second step is hash joining. Where is here? It is the color code join, and this is the one prod table and view and prod table. So up to here, this thing is processing here. Up to this second step, this is the processing happened. And now moving to the step 1, hash group by. This is the green color. So this is the whole operation, whole select statement. Inside this green color, this is the whole thing happened. Okay, like this. And given the output to select statement. This is the color code of select matches here. So output will be given to the client. Okay, now let's see in the database. We will connect to the database from SQL developer and we will see there. Okay, this is the PDB I have connected. Let's see what are the things available in the products table. So these are the data. This is the data available in the products table. This is the prod ID. Okay. If we check the counts, what is the count of this table? Control C. Here, count of star. If we check the count, so it is having 767 rows. Now check the count of the tables. Table sales. SALES sales. See, it is having 489K rows. Okay. So let's check data, how the data is looking inside the table of sales. Here, if we see the data, so it looks like this prod ID, amount of sold. So we are performing average of this amount sold. Okay. So now what we will do, we will take that subquery from the document here. We will take the subquery first. Copy here and paste here. Okay, this is the subquery. So what it is doing actually, in the sale table. This is the sale tables and this is the data of the sales table. What it is doing? It is taking the sum of the amount sold. Sum of the amount sold. This column it is taking as sum, as sum amount, and count. The count of this sales table. The count is 489K as count amount. Okay, let's run it. It is grouping by prod ID. Okay, prod ID. How many prod IDs we have? We have only 769 prod IDs based on that products table. So we have here, we will get 767 rows. Here see, we will get 767 rows. Why means we have only 767 prod IDs. That's why we will get 767 rows. Group by prod ID here. For each prod ID, for 50th prod ID, it is having count this many of rows. 633 rows we have in the sales table based on this product ID, and the sum of amount for all these rows, 633 rows will be this much. Okay, similar kind to 23, 521 like this up to 767 rows. Like this, the view underscore GBC here. The view underscore GBC will convert 489K rows here, 489K rows to this 767 rows here, 767 rows. If we go down, 767 rows. Okay. So now what we will do, I have opened another window. Okay. We will copy the whole SQL query here, this one. Now, so what I will do, I have copied here whole SQL query and ran this. It is given only 5 rows. Why means, so what actually happening here in this SQL query? So here what it is taking, view some amount column from the view. Okay, it is dividing this with sum of this count, view of count amount. See, this is the view, right? We have, this is the view. This is the view GBC. Okay, here sum of amount, sum of view dollar sum amount. This is the sum amount column. It is taking all this sum of this column, whole 767 rows. Okay, it is taking sum here and again dividing it by sum of view view dot count amount. Count amount is the, this is the column. This is, if we add all this, it will become rows. How many rows? 489K rows. Okay, that is taken as here. So total amount, total sum of the amount divided by count of that rows will become as a average. Okay, now you got the point. So this is the, this is what it actually discusses in the document here. If you go here, average, where is the average? Average part, average part. Here, see, average of group A plus average of group B not equal to average. So it is taking, what it is taking, sum of group A amounts and plus sum of group B amounts. Here it is group B. Count of group A rows, count of group B rows. So this is happening here. What it is taking, it is this is the group A. Again it is forming group B. How it is forming group B? Taking sum of this and taking sum of this, counting average here. So like this average will be processed. Okay, we get finally 5 rows based on the product category. Okay, group by product category here. Okay, we have only 5 categories. If we go to the products table, if we go to the products table here, we have only 5 categories. How you can check? Select distinct to which column name? product category, right? Yeah, this one, prod underscore category, prod underscore cat category, where it is category, distinct category from products. Select distinct. See, we have only five categories. So grouping by this, we get only five rows. And for that, for electronics product category, we got average amount sold is this much. And like this, for all, it has calculated. Now let me run the original query. Okay. See here, this is the original query we have, right? We will check the output by running this SQL query also. I will take the third tab here and I will paste here. See, this is the original SQL query we have. Here, average function is using. Okay, internally the query will be rewritten as like this by the SQL, by the Oracle optimizer engine. Okay, so if we run this, see, we got the same output. We got the same output. So internally, these are the things happening to reduce the cost. Okay, to increase the response time. So this is the beauty of Oracle optimizer. Okay, I hope you all understood the concept of this explain plan, how to read and interpret execution plans. Okay, so we will discuss. I will discuss another explain plan also in the next video. Like suppose if this indentation is going right side, right? Yeah, if the indentation is going right side and coming to left side also, how it will, how to interpret that explain plan. Okay, I will take that explain plan. I will generate one scenario and I will take that explain plan as per requirement, and I will prepare a video and I will share here. Okay. Thank you. Thank you for watching. Bye bye.